Welcome to the section 1 of the ionic compounds. Let's begin.
Alright, so here's a little bit of an introduction to ionic compounds. Basically, a chemical bond is a force that holds two ions together. And within a chemical bond, or an ionic bond, you have a cation, which is a positively charged ion, and it comes together with an anion, which is a negatively charged ion. So when you have ionic compounds, a cation and an anion come together and they form an ionic compound. And then we're introduced to valence electrons, which are the electrons in an atom's outermost orbitals. And this can be looked at through a variety of different models and diagrams. Particularly, we have the off-boo diagram. And I'm going to demonstrate how we can, by looking at an element on the periodic table, we can fill out this wonderful chart. So,
and from calcium, looking at it on the periodic table, I'm going to draw in the electrons in the boxes. So basically the rule is, I'm going to draw an arrow. So you draw one arrow, that represents one electron. But each box has two electrons, so then we're going to keep going. And we need to make sure we go up to 20. So we have now 4, and basically the rule is you get 2 boxes, you have to draw each one individually in the boxes and then add the next one in. So we have 2, 4, 6, 8, 10, then we just need 10 more. Down, down. 2, 4, 6, 8, 10, 12, 14, 16, 18, and perfect, we have 4 s. This is going to fill up the entire thing, and this represents all the electrons within calcium.
okay, so a crystal lattice is a three-dimensional geometric arrangement of particles. I would say that this would be a mineral, generally a mineral. So one of the examples I can think of is something called barite, which is in the form of a crystal lattice. We move on to an electrolyte, which is an ionic compound whose aqueous solution conducts an electric current. So aqueous means that it is a solution, so it can be a liquid mixed with some other form of maybe like a solid into a liquid, and it mixes. That's what aqueous means, and it conducts some sort of current, so it has a charge. Electrolytes can typically be found in most energy drinks these days. The most common known would be like Gatorade or something, and electrolytes are good for you when you're sick, or especially if you exert a lot of energy and you're exercising a lot, you lose electrolytes, so you need to replenish your body with them. That's why it's not really good if you're not really active and if you're healthy to be giving your body excess of electrolytes. And last, we have lattice energy, which is the amount of energy required to separate 1 mole of ions in an ionic compound. All I know is I think that takes a lot of power to do.
So the electron dot structure just shows the amount of valence electrons in each element. So here you can only have up to 8 valence electrons. Here is a noble gas, neon, and all the noble gases have the full valence electrons. So this one will have 8 dots around it, and when you draw them, you do counterclockwise, starting with the right, and you just do 1 dot at a time until you fill up the amount of valence electrons. You can get the amount of valence electrons from the group that the element is in on the periodic table. And then here we have aluminum, and it's in group 13. So it has 3 valence electrons around it, and you just go this way. And then this one, the electron configurations, are based off the off-boo diagram that we showed earlier. So for aluminum, you just write how many arrows it would fill up in each of the little sections with the boxes. So it filled up 1s1, 2s2, 2p6, 3s2, and 3p1 because it only has 13 electrons in it. But that's the long configuration, and when you do the short configuration for aluminum, you use the closest noble gas to it that doesn't go over it in amount of electrons. So it would be neon, and then 3s2, 3p1, and that would give you 13. And then this is the Bohr's model, and it is also used to show electrons. But unlike the electron dot structure, this one shows all the electrons. So on your first ring, you always have 2, unless you have hydrogen, which only has 1. But you always fill up 2. And then, since this is a noble gas, this second ring will have all 8, showing the 10 electrons that it has. But if you went bigger than this, then each ring would fill up with 8 until you got to your valence electrons. And then you would just put as many valence electrons as it has. And this again goes counterclockwise like that.
I'm here to educate you on ionic compounds. An ionic compound is made up of an ionic bond, specifically a non-metal and a metal together. The chemical formula of an ionic compound is called a formula unit, and this is the simplest ratio of the number of ions involved.
There are 2 types of ions, monatomic ions and polyatomic ions. These are examples. Magnesium is a monatomic ion. Ammonium is a polyatomic ion, just like the stuff in your newspaper.
So oxygen is a type of polyatomic ion that is composed of a nonmetal and 2 or more oxygen atoms. For example, there's nitrate.
These are the properties of metals. Alrighty, so section 2.
So oxygen is a type of polyatomic ion that is composed of nonmetal.
Are you serious? Hello, I am here to educate you on ionic compounds. Exhibit A. An ionic compound is a compound that is made up of an ionic bond, specifically a metal and a nonmetal together. The chemical formula for an ionic compound